Hello and welcome to Models of the Atom Throughout History. Today we're going to be talking about two of the first scientists who developed models of the atom. First up, we have Democritus. Democritus was an ancient Greek philosopher, and because he was back in 400 BC, his tools and technology were pretty rudimentary. That means that they weren't very advanced. So basically, philosophers were people who sat around and did thought experiments like, I wonder what happened, what this is made of, or I wonder what could happen with this or that thing. So Democritus decided to think about what happens when we divide matter. So what you see on this slide are supposed to represent pictures of gold, right? Gold is an element. And so what would happen if we had a big block of gold and then divided it in half and then divided it in half again and then divided it in half again and again and again and again and again until we get smaller and smaller and smaller and smaller. We can't see it anymore if we divide it small enough. So that's what Democritus was thinking about. Is it still gold when you divide it in half the first time? Yeah. If you divide it in half again, still gold, still gold, still gold, as you go smaller and smaller and smaller. So what Democritus thought about was that matter is made from fundamental particles that are indivisible and indestructible, right? You can hit it with a hammer, it's still going to be gold. You can blow it up, it's still going to be gold if it's if it is pure gold. You can melt it down, it's still going to be gold. Indivisible, right? It sounds like invisible, right? And if we get it small enough, we can't see them. But indivisible means it can't be divided anymore. Once we get down to that fundamental particle, it can't be divided anymore. And so that's what he called it. Atomos is the Greek word for indivisible, can't be divided. And that's where our word atoms comes from. Atomos is the Greek word for indivisible. Moving forward in history until the late 1700s, early 1800s, John Dalton was an English school teacher who liked to experiment in his free time. He wrote a lot of articles and books about chemistry and physics, and also color blindness. He was the first person to actually write about it and make it a real thing. So because of his experiments with chemistry and physics, he is credited with creating Dalton's atomic theory, right? It's named after him. His experiment was that he took different containers of gas and he tried to react them and combine them and discovered a lot of things by when they did react or when they didn't react. And so because of what he discovered, he came up with his atomic theory. It comes in a couple of different parts. First is that elements are made from tiny indivisible particles. These are called atoms, right? The tiny indivisible particles, atoms. He agreed with Democritus about this, but because he was able to do experiments because the technology was better, he was able to find out some more stuff about the atoms. The second thing he found out was that atoms of the same element have the same mass and size. So a carbon atom is the same as all of the other carbon atoms, right? We have a blue one there equal to the blue one there. But if it's a different element, right? If you're comparing carbon to gold, these elements that are different have different masses and different sizes, right? This little blue ball is not the same as this red ball, right? So if we think of these little balls as atoms, atoms of the same element are the same, atoms of different elements are different. The third part of his theory is that atoms of different elements can combine. We can combine them chemically or physically. Physically means that there's no bond that's created, so we can just sort of mix them up, sort of like a peanut butter and jelly sandwich, right? We can put bread and peanut butter and jelly together, but they don't make anything new. It's just those things near each other. But if they combine chemically, right, we have a new bond that's formed. They're touching. If they combine chemically, it has to be in whole number ratios, right? 1 to 1 is a ratio where you have one of one kind and one of the other kind. 1 to 2, where you have one of one kind and two of the other kind. 2 to 3, etc., right? Whole number ratios. And that's because of what atoms really are, right? Once an atom is a particle, right, it's the smallest piece of matter. We can't divide it in half anymore. So these ratios have to be whole number ratios because we can't divide them anymore. So whole numbers. And then finally, atoms can be joined or separated or rearranged in a chemical reaction, but we can't change one into another. So, for example, in this reaction on the left, we have two green atoms combining with one purple atom to make a green and purple compound together, right? Those are atoms being joined in a chemical reaction. This arrow sign means that a chemical reaction is happening. Or the reverse of that, right? You could take this compound, this green and purple compound, and separate them in a chemical reaction to form the purple by themselves or the green by themselves, right? We can join them or separate them in a chemical reaction, but we can't make a new element from previous elements. So two greens plus a purple do not equal a blue, right? You cannot make something make a new kind of atom or a new kind of element just by combining them, right? They're kind of like Legos, right? You can stick them together, you can pull them apart, but if you smush them together, you can't make a different kind of Lego piece. And that is Dalton's atomic theory.